Hello, my name is Akash Mudalgiri. Today I'm going to be explaining the shortest distance traveled by a knight from source to given destination using the data structure queues. My USN is 1RV21CS016. Table of contents. First we'll take a look at problem statement, then a slight introduction towards our solution, an algorithm, um, standard protocol, then I'll give you an explanation of the algorithm, then we'll look at the code and we'll run the code using Visual Studio Code, and I'll also tell you about the applications of similar codes. The problem statement: given a square chessboard, the position of the knight and the position of the target are given. We need to find the minimum steps taken by the knight. Knight, in simpler terms, it's called horse, right? Will take to reach the target position. Now, let's take a look at this chessboard. Um, in basic chess, it's a square board of 8 into 8 size. 8 in length and 8 in breadth. So total 64 units are is the measure of the chessboard. So a knight or the horse moves in the shape of L, as we all know. So first, let's assume our knight to be in this square. So the possible next moves for knight is either it goes to b6, f6, E7, C7, um, E3, C3, B4, F4. As you can see, these all constitute and make a L shape. This is how we get the possible next moves of this knight. So when it's in the center of the board, we have one, two, three, four, 8 possible directions where the knight can head to. From one square, it has 8 different options to choose its next move. But it's not the case for every square, because this is the center square. You have all the 8 positions open. But whereas it's somewhere in the corner, the knight can only move. The knight's movement is limited. So let's say we have this square over here. Its movement is limited. So there is one move here and one move here. So from 8, we have only 2 movements at the corners. Now, our problem statement, now we know how the knight moves. Now, first step is to create the 2D matrix to visualize the chessboard. This is the standard chessboard. Instead of this, let's go with something familiar. Our 2D matrix, which acts as a Cartesian plane, starts from 0 and goes up to 7 horizontally as well as vertically. So we have our 0, 1, 2, 3, so on and so forth. Any unit or any cell in our 2D matrix can be represented as x comma y. That is the vertical distance to horizontal distance to vertical distance. So this cell here is 3 comma 6. Similarly, this cell here is 7 comma 7. All right. Now, um, say our knight is in 3 comma 4. Our knight is in 3 comma 4. Now, uh, let's closely look at the possible paths of our knight. Since we know there are 8 paths, one is over here, here. here. So if we observe carefully, we have a particular set. So from our night being at 3 comma 5, it can travel either two steps towards the right and one step vertically up, or two steps to the right and one step vertically down. That is, we are covering two steps to the right and one step vertically up, two, uh, two steps two steps horizontally and one step vertically down. So we have covered these two. Similarly, in these two ways of moving the night, if we observe carefully, we are traveling 2 units upward and 1 unit towards the right or 1 unit towards the left. Now we have these two cases which we'll deal with now. That is, we are moving two steps backward and one step upward, or two step backward and one step downward. Now, the last or two possible ways the knight can travel is two steps downward, one step forward, two steps downward, one step and one step backward. So we have one, two, three, four, five, six, seven, eight, eight different operations which can be performed for a cell where the night is, and we can determine where the possible next eight or the next eight the directions the night can head to. So what we do is we store this operation as another array, as another array. So when we add the position of the night and the elements of the array in X and Y fashion, you'll be able to travel to different positions the night can travel in its next step. First, to implement this program, we create a 2D matrix representing our chessboard. Initially, each of the units in this 2D matrix is initialized to -1. Only the source, say this is our source, is initialized to 0, stating that this is where the knight will start its motion. So, say there is a destination, this is our destination, which is 7 comma 0, and this is our source 3 comma 5. So using the seven array elements which we have mathematically defined and determined how the knight moves, now we'll start applying the +2 -1 configuration to predict where the knight would move next. There are 8 possible paths from the center. Uh, Say our knight moves here, our knight moves here, or our knight moves here or here. So each of the 2D matrix unit cell is initialized to -1. Since each of these cells are initialized to -1, uh, we will change the memory of this particular cell to 1. Each of this will now have 1 stored in the memory. Even this will have 1, this will have 1, even these will have 1. All the first possible knight moves will have 1 from source. Similarly, from here, let's say the knight will again the knight is over here and it has to travel. So the knight will be here and it has to travel. So from each of the first moves, say the knight is in each of the one squares, and it will again re-execute the program, which shows how the knight moves. So from here, say the knight moves here, the knight moves here, and the knight moves here. So all these three units will be initialized to 2, which signifies it requires two knight moves for the knight from source to reach this particular square. Similarly, from here, if the knight moves here, this this cell will be given 2 into its memory, and this cell will also be given 2 to its memory, so on and so forth. And from here, reaching destination, it takes another move, so the destination will be assigned 3. We store, so to process the algorithm, we create a queue and we store source in the queue. Later, we start storing all the possible knight moves to the queue, and once the queue is not empty, we start dequeuing the queue. While dequeuing, if the destination and the dequeued element shall match, the function will return the value of the value stored in destination. So say our destination is 7 comma 0, and after our function executes 7 comma 0, which was first initialized to -1, um, shall be now initialized to 3 due to the number of knight moves, and since 7 comma 0 matches our destination, uh, 3, which is now in its memory, meaning which is now in 7 comma 0, 3 is the current value, so this value shall be returned. Say our destination was not 7 comma 0, rather 1 comma 1. Since the value stored at 1 comma 1 is now 2, 2 shall be returned. If destination is 2 comma 2, sorry, 1 comma 1. Similarly, if our source and destination are same, it will return 0. So this is how the program to find the least moves performed by knight to reach destination can be executed. Now let's write the code, analyze, and implement it through Visual Studio Code. Before we start executing our code in Visual Studio Code, let us analyze what we have to enter as inputs for our code. So let's take our source or the knight to be at 0 comma 0 and original, and in one move it will initialize this unit or this cell to be 1. So you see, if we make this our destination, that is 2 comma 1, it should hit to this unit in one move. And let's make another move, which is 3 comma 3. So it will have initialized this unit to 2. That is, it takes 2 moves to reach this position. And last, let's take another move from 2 from 1 itself and travel here. So this will be the third move. Sorry, this will be the second traversal again, and the it will initialize 2 to this unit, and the address will be 4 comma 0. Let's check these three values and confirm. Let us compile and run our code. So since we have discussed, we will take the same 0 comma 0 as our initial position and our destination. First let us check 2 comma 1. It is showing one step, so it is proper. So let us run the code again, again for 0 comma 0, and this time let's give 3 comma 3 as discussed. It's showing two steps. Fine. Now let's check for the last time again with origin, and this time let's change the direction to 4 comma 0, and we have to again obtain two steps. Yes, it is giving me two steps. The code is implemented successfully. Thank you. Similar codes can be used to create images on IPS LED screens, pixelating and depixelating in OLED screens, and also in image processing. Thank you.